In my last video, we started to look at the binomial expansion. We looked at expanding binomials to positive integer powers. In the video, we used Pascal's triangle to find the coefficients that we needed on each term. In this video, we're going to look at an alternative approach, and that's called the nCr method. So we do exactly the same in terms of finding the expressions we need. This just gives us an alternative way of finding the coefficients we need. This method is easier when we have higher powers. It allows us to avoid writing out line after line of Pascal's triangle. It also makes jumping to a term significantly easier. I must stress this method of finding the coefficients is also only useful when we have n as a positive integer power. So for example, if we had -2, a quarter, -1/2, we wouldn't use this approach. In later videos, we will look at the approach required when we have a power that is not a positive integer. So let's go back and do a bit of recapping on the last video. To find our coefficients, we used Pascal's triangle. We had 1, 1, 1, we had 1, 2, 1, we had 1, 3, 3, 1, we had 1, 4, 6, 4, 1, we had the next line, which was going to be 1, 5, 10, 10, 5, 1, and so on and so forth. Let's say we had a binomial which was a plus b to the power of 3. I would just go ahead and use Pascal's triangle. But if we had a plus b to the power of 12, I'd look to use the nCr method. To get started, we're going to go through the nCr method in a very formulaic way. Later in the video, I'm going to explain exactly what it means and how it works. But to begin with, as I clearly understand this is quite a bewildering topic for some students, we will just look at a very formulaic approach of using the nCr method instead of using these particular lines of Pascal's triangle. So let's go ahead and do a plus b to the power of 3. We're going to choose this line of Pascal's triangle, the fourth line, and this corresponds to the third power. So we can see the powers are just here. Okay. So what we're going to get then is 1, that's our first value. Then we'll have a to the third, let's write that, and then we'll have now b to the 0, plus 3. We'll have a to the power of 2, we'll have b to the power of 1, plus 3. We'll have a to the power of 1, we'll have b to the power of 2, plus 1. We'll have a to the power of 0, and we'll have b to the power of 3. We can see the powers of a are descending from 3 to 0, the powers of b are ascending from 0 to 3. So a goes from n to 0, b goes from 0 to n. So just tidying this up, we're going to have now a cubed plus 3a squared b plus 3ab squared plus b cubed. And we've seen that expansion before. What I'm going to do is just go ahead now and highlight the coefficients, and instead of writing the coefficients, I'm going to introduce the notation nCr. nCr is written like so. So let's go ahead and do this. We have a small n, large C, and r. So what I'm going to do is just go ahead and look at this particular line. And I'm going to write on that this value is 3C0. This one is 3C1, this is 3C2, and this is 3C3. These values can be found on a calculator. Later on I'll explain how you find them manually and also a bit about them. But this simply says 3 items chosen 0 ways, 3 items chosen 1 way, 3 items chosen 2 ways, and 3 items chosen 3 ways. When we look at an expansion, it will make sense. So all I'm going to have now is the following. So if I had my expansion of a plus b to the power of 3, I would have 3c0 instead of the 1. Exactly the same. I'd have now a to the third and then b to the power of 0, plus the next one, 3c1. Then we'd have now a to the power of 2, and we'd have now b to the power of 1. This value on the term here, the b term, corresponds now to the value here of r. The next one, 3c2. We're going to have a to the power of 1, we'll have b squared, plus 3c3. Then we'll have now a to the power of 0 and b to the power of 3. The only thing that has changed now is that I'm using now the nCr method to find these coefficients. And again, with the power of 3, I would do it with the Pascal's triangle. But if it was a power of 12, we've had 12c0, a to the 12, b to the 0. So how do we find those? Here's our calculator, and all we do is press for the first one 3, then it's shift divide. That's our nCr. Then we put in now 0, and that is going to give us 1. So we can see that we found 1. We know that is anyway. We've just done it. 3c1 is going to give us 3. 3c2 is going to give us 3. And then 3c3 is going to give us 1. These are symmetric, and again later on when we do the explanation of this, we will see exactly now how this works. So let's look at the advantage of this. Let's do 2 plus x now to the power of 12. This now, and I'll just do the first 3 terms. We would get 12c0. We would get now 2 to the power of 12 x to the power of 0. Plus 12c1, we would have now 2 to the power of 11, we would have x to the power of 1. So let's do 4 terms. 12c2, we'd have now 2 to the power of 10, we would have x to the power of 2. Plus, then we'd have 12c3, and we'd have 2 to the power of 9, and then we'd have now x to the power of 3. So I can get these coefficients by simply using the calculator. Now this one will give me 12, that one will give me, this will give me 1, that will give me 12, and so on. So all I do is write in 12 shift divide. That's the nCr button. If you put in that, that's going to give us 1. If you put in 1, let's put this in, it's going to be 12. And then afterwards, we've got now 2, and that will give us 66. And then if we want to put in now the 3, that's going to give us now 220. So what we've got then, if I just list these out, we could just go ahead and put these on. So it would be, and as I said in the last video, you're going to need a calculator on some of these. 2 to the power of 12 is, what's that, 4096, 2 to the 12. So 2 to the 12 is going to give 4096. So we could just write this out as now 4096, and then anything to 0 power is 1. Then you're going to have your 12, then you're going to have 2 to the 11th, which is 2048, and then you're going to have now x to the power of 1. Then the 12c2, and we had 12c2, let's put that back in, 12 shift. So I often turn it off when I go ahead and do that. So 12c, we wanted 12c2 as well, didn't we? 12c2, so 66, so 66, then 1024, then we can have x squared, and then this was the 220, 2 to the 9th is going to be, what's that, 512, 512, and then we'll have now x cubed. And we'd be expected to tidy that up, so we'd be expected to write these out. And as you can see, it's a bit of a hassle. Now, let's say we had 2 plus x to the 12th, and we wanted the term in x to the 8th. So if we wanted the term in x to the 8th, instead of using Pascal's triangle to list this all out, we can just jump straight there, and that would be 12c8. We're going to have now 2 to the power of 4, and then we're going to have now x to the power of 8. So if we can work out 12c8 and then times it by 2 to the 4th, then we've got the coefficient of the term in x to the 8th. So I can just work this out. So 12c8. 12c8 is 495 times by 2 to the 4th, which is 16. That's going to give us 7920. So 7920 x to the 8th. So that's the term in x to the 8th. I've just jumped to it. Okay, so 12C8 is going to be the same as 12C4. These are symmetric. And again, the reason is, if I just write this out, when we look at nCr, nCr is actually given now as n factorial over r factorial n minus r factorial. So if we just consider now this one right here, what we've got is 12C4, and then we're going to have now, this is going to be 12C4 will be 12 factorial over now r factorial, which is 4 factorial, and then we're going to have n minus r. Well, that's going to give me 8 factorial. So you can see now that this would be the same as 12C8, and that gives us our symmetry. So the take-home message is, before we go on to really look at what this means, the take-home message is we do exactly the same. We find now the descending powers of A, the ascending powers of B, and instead of putting the coefficient in front, we go ahead and write out the nCr. So if I did the next one, this one right here is 4C0, 4C1, 4C2, 4C3, and then 4C4. This one, 5C1. Now this one, I'm just going to write slightly differently because we can use different notation. We can write it as 5-0, 5-1, 5-2, or 5C2, 5C3, 5C4, and then 5C5. So that's what we get. So what we can write then, if we go ahead and do this, and again, this is for positive integer powers of n, and you might want to write this down or just refer to it in the exam book. A plus b to the n is going to be nc0. We will have a to the n and then b to the 0, plus nc1. We'll have a to the n minus 1, b to the first, plus nc2. We'll have a to the n minus 2, b squared, right the way up to ncn. We will have a to the 0 and then b to the n for our finite expansion. So if we've got now n here, we've got n plus 1 terms. As stated, you don't have to remember that. That's given in a formula book. All you've got to do is apply it like so. So let's move on. If you want to skip the next bit, this is explaining what nCr means. If you just want to go on to some of the questions, I'm going to do some questions later in the video. So these are the ones that I'm going to do in the video. What we're going to do though is just look at this idea of nCr. So this comes from combinations, so different ways that things can be arranged where the order doesn't matter. And this is given as a calculation as n factorial over r factorial n minus r factorial. So what does this mean? N items chosen r ways. Well, let's just choose 3 items. I'm going to have some animals. Let's have a cat, a dog, and an elephant. Okay, so these are my 3 items. What I want to know is how many ways can I choose none of these? The answer is just one way. It's just to have none. So I've got 3 items chosen 0 ways. Well, that is just going to give me 1. What about if I have 3 items and I just choose 1 from there? How many different ways can I do that? Well, I can have a cat, a dog, or an elephant. Well, there are 3 different ways. What about if I have 3 items and I choose 2 of them? Well, let's just think about that. I can have a cat and a dog, I can have a cat and an elephant, or I can have a dog and an elephant. Remember, the order doesn't matter. We're talking about combinations here. Permutations consider order. 3 different ways. Okay, how many ways can I choose 3 animals? Well, the answer is just 1. That would be a cat, a dog, and an elephant. You can only do it once. So we can see how this works. 3C0, 3 items. How many ways can we choose none of them from there? Well, the answer is 1. How many ways can we choose 1? Well, on here, if we think about it, we've got a cat. I'll just write this out. Cat, a dog, or an elephant. What about 2? Well, again, cat, elephant, dog, elephant. What about 1? Cat, dog, elephant. Okay, so let's look at that now with 4. Let's introduce a frog. Okay, so if we introduce a frog, what we've got is 4 items, and if we have now, how many ways can we choose 0? Well, the answer is just 1. It's just not choosing any. What about how many different ways can we choose 1? Well, we can have now the cat, the dog, the elephant, or the frog, so it's going to be 4. What about 2 different animals from the list? Well, I can have a cat, a dog, a cat, an elephant, a cat, a frog. I can have a dog, an elephant, a dog, a frog, and an elephant and a frog. 6 different ways. What about 3 of them? 4C3. 4 items, and how many different ways can we choose 3? So if we consider what we'll have a cat, a dog, an elephant. We can have a cat, a dog, and a frog. Perhaps we should have gone for fish to avoid this. We could have a cat, an elephant, and a frog. We can have a dog, elephant, and a frog. Or we can have on here, is that all of them? Let's have a look. Yep, that's all of them, isn't it? Cat, dog, elephant, cat, dog, frog, cat, elephant, frog, dog, elephant, frog. 4 different ways. So let's do the next one, 4C4. How many ways are there of choosing 4? Well, there's only one way, because you can have a cat, a dog, elephant, and a frog. There's no other way of doing it. Remember, the order doesn't matter here. It's not as if I'm doing permutation. So cat comes first in the first one, cat comes second in the next one, and so on and so forth. So you can see now from this that we're building up these. And again, this is Pascal's triangle, but it just gives us those. So you're probably saying to yourself, what on earth does this have to do with the binomials? Well, let's go back now to our a plus b. So a plus b to the power 3. I'll only do to the power 3. Remember, we can write this now as a plus b, and then we've got now a plus b, and then we've got a plus b. Now we know that this is going to give us a cubed plus 3a squared b plus 3ab squared plus b cubed. We've seen that. That is what the expansion is. What I'm going to do is just consider a table now and work out how we're going to get each of these. So if I just put this on, let's go ahead and do that. And then we'll put that like so. So let's just, in fact, we'll move these along just a little bit. Okay, and right, there we go. That's what it's going to look like. So what I'm going to consider now here on each of these is the following. So let's put that just there. So in the first one, I'm going to look now at the following. We're going to have now, and we'll start here. So this one is going to be now the a cubed. This will be the a squared. This is going to be a to the power of 1, and this is going to be a to the power of 0. So I think to myself, if I multiply through the brackets, how many different ways can I get a cubed from multiplying the terms? And the answer is the only way I can do it is a from the first bracket, a from the second bracket, and a from the third bracket. So it's a. Now that is going to give me one way. What about a squared? Well, I could have a, b, that's one way, a, b. I could then have a, b, a, so a, b, a, or I could have b, a, and a. That would give me the a squared. So b, a, and a. How many different ways? 3. What about a to the first? Well, if we consider, I could have a in the first one, b and b. I could have on the next one b, then a, then b. And finally, I could have b, b, and a. Well, there are 3 ways which I could generate a term in a to the first. Now, if we look at a to the 0, well, avoiding a is just b times b times b, 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 and b, and that is going to give us 1. 3c0, 3c1, 3c2, 3c3. Now, what are these? Well, these are the powers of b, 0, 1, 2, and 3. In the same way, now we can see the symmetry. This is b to the 0, b to the 1, b squared, b cubed. So I'm just considering how we find each one. And you can see the symmetry by writing out a instead of b. That's what gives us those coefficients. So hopefully that makes sense. You don't need to know this. I just think it's important rather than just saying this is what it is, accept it, do it. I really don't think so. Okay, sometimes you'll be asked to calculate these without a calculator, if that doesn't make too much stupid sense. nCr is going to be n factorial over r factorial, then n minus r factorial. So factorial is simply now the numbers previously multiplied. So for example, if we have 5 factorial is going to be 5 times 4 times 3 times 2 times 1. 3 factorial is going to be now 3 times 2 times by 1. And then if we had 1 factorial is going to be equal to 1. And if we have 0 factorial, that too is going to be equal to 1. I'll let you do the investigation on that, but again, if you type it into a calculator, you'll see that that is going to be the case. So let's just go ahead and find our factorial button. My eyes are not doing too well. There we go, factorial. Okay, and that gives us 1. It's really quite interesting when you look at that. So let's go ahead and look at this one right here, 3c2. So we've got 3c2, so this is going to be 3 factorial over now 2 factorial, and then we've got n minus r factorial, which is just going to give us 1 factorial. So all I've done is plugged it in. So hopefully you can see that 3c2 is going to be the same as 3c1 as we've done this. So what this is saying is 3 times by 2 times by 1 over 2 times by 1 times by 1. We can see these cancel, and they're going to give us now, that's going to give us 3. And we know 3c2, we've seen that on the calculator. If we type it in 3 shift, then we've got the 2, and that's just there. So that's 3. What I might have done is said that this was actually 3 times by 2 factorial over 2 factorial times by 1. Cancel those off, 3 over 1 is 3. So that's a nice way of doing it. Okay, 5c3, 5 items chosen in 3 ways. So we're going to have 5 factorial, and then we're going to have 3 factorial, and then 2 factorial. So what could I write? I could write this as 5 times by 4 times by 3 factorial over now 3 factorial times by 2 factorial. Now 2 factorial is just 2, it's 2 times 1. We can see that those are going to cancel, and we can see 5 times by 4 over 2 is going to give us 10. Again, we can check that. You wouldn't be expected to do these every time you're calculating them, but again, it's an example of a question you might be asked. So by symmetry, you can see that 5c3 is also going to be the same as 5c2, because we would have had exactly the same here. R factorial is just going to be n minus r factorial. Okay, 4c1 should be quite straightforward, so it's going to be 4 factorial over now the following. We're going to have 3 on here, 1 factorial, so 1 factorial, and then 3 factorial. Well, I could write this now as 4 times 3 factorial over 3 factorial. Those will cancel off. That's going to be 4, and we knew that anyway. Okay, let's look at this one right here. This is just like saying 7c5. So 7c5, well, that's going to be 7 factorial over 5 factorial times by 2 factorial. So I'm going to write this as 7 times by 6 times by 5 factorial over 5 factorial times by 2. They will cancel, and that's going to give me 42 over 2, which is 21. If you're not understanding what I'm doing here with the 5 factorials, that's perfectly fine. Hopefully I showed it here that 3 times by 2 factorial is 3 factorial. It's logical. N times by n minus 1 factorial is n factorial. And that's where this proof comes from. But again, look at that if you wish. Okay, let's actually move on and use this, because I've been doing a lot of talking. In question 4, it says use the nCr method for finding coefficients to find the first 4 terms in the expansion of the following. So we got 1 plus 2x to the 6. So we'll have 6c0, we'll have 1 to the 6, then we'll have 2x to the 0. Plus 6c1, we'll have now 1 to the power of 5, we'll have 2x to the power of 1. We'll have 6c2, we'll have now 1 to the power of 5, 1 to the power of 4, and then we'll have 2x, which we need to raise to the power of 2, plus 6c3, and then we'll have 1 to the power of 3, and we'll have 2x to the power of 3, plus ... and it'll continue. So 6C0 is 1, that's going to give me 1, that's going to give me 1. So all I'm doing is simply now putting 6C0 as 1. If you need to check, again, straight through the calculator, 6, then we're going to have C0, that's going to give us 1. Okay, 6C1 is going to give us 6. Okay, so 6C1 is 6. Again, if you want to check that, all you're doing now is switching this over, and we'll put in 1, so that's going to give us 6. So we'll have 6, we'll have 1, and then we'll have 2x. 2x to the power 1 is just 2x. 6C2. So again, all we're doing is going into the calculator. I wouldn't work it out manually. We just look at it, and that's going to give us 15. So 15, then we're going to have 1. 1 to any power is going to be 1. If it's negative 1, we know what happens with the odd and even powers. Be careful on this one. Some students put 2x squared. It's 2x squared. So that becomes 4x squared. Okay, 6C3, if we go ahead and put that in, 6C3, we've seen this one again on our Pascal's triangle. That's going to give us 20. So plus 20, and then we're going to have now 1, and then we'll have 8x cubed. So what do we get? We get 1 plus 12x plus 60x squared plus 160x cubed. Job done and sorted. Again, you might have wanted to have used Pascal's triangle on the 6th power, entirely up to you. I'm certainly not going to use it as it's a lot of hassle. Okay, 3 minus x to the 10th. So we'll start with 10C0. We will have 3 to the power of 10, which is going to be huge. We'll have negative x to the 0 plus 10C1. We've got now 3 to the power of 9. We've got now negative x to the power of 1 plus 10C2. We've got now 3 to the power of 8. We've got negative x to the power of 2 plus 10C3. We've got 3 to the power of 7. And we've now got negative x to the power of 3 plus ... as we're going to have more terms. Okay, so again, I'm going to write this out. I'll just do it. In all reality, I'd want the next line to show what each of these is. But we know 10C0 is 1, so all we need is 3 to the power of 10. So 3 to the power of 10, that's going to give 59049. So 59049. Now, if you wanted to do an extra line, I'd just bracket that off, put that's 1 and that's 1. Okay, 10C1. Well, 10C1 is going to be 10. Again, if you want to check that, 10 shift 1, that's 10. And then we're going to multiply this by 3 to the power of 9, and that's going to give me 196830. Now, I've put a plus here, but we know that this is going to be negative. So 196830. So let's put that in. So that's a negative. 1968, so 1968 30x. Okay, 10C2, okay, if you want to work that out, you can do. It should be 45. Let's just try that. 10C2. So 10C2, 45, and then we're going to get times by 3 to the power of 8. What's that going to give? 295, so 295,245. So plus 295, so 295,245, and that'll be positive. And you might have said, well, how did I know it's 45? Well, it's going to be 10 factorial over 8 factorial, 2 factorial, or the other way around. So essentially what it is 10 times 9 times 8 factorial over 8 factorial times by 2 factorial. 2 factorial is just 2. So that's 90 over 2, which is 45. Yeah, so there we go. Next one, 10C3. So 10C3, again, you can work this out if you want. You won't be judged on doing it unless you're actually just asked to work it out. So 10C3, 120 times by 3 to the power of 7. And that's going to give us 262440, and this will be negative. So negative 262440 x cubed. So there we go. That's the first 4 terms. Again, the advantage of this, if we wanted now the 7th, the term in let's go for term x to the 7th, x to the 7th. The 7th term would be x to the 6th, but we'll go for this. So if we wanted the term in x to the 7th, what we would do is put 10c7, then we'd have 3 to the power 3, we'd have negative x to the power of 7, and we would just work that out. So 10c7. Now 10c7 is the same as 10c3. So 10c3 we've just seen is 120. 120 times by 3 cubed, and then we'd have a negative as is an odd power. Right, 2 minus 3x to the 8th. So let's do that one. So we'll have now 8c0. We need first 4 terms. So 8c0 we'll have 2 to the power of 8. We'll have negative 3x to the power of 0. Plus 8c1, we will have 2 to the power of 7, and then we'll have negative 3x to the power of 1. Remember, this number here corresponds to the value of r, that's the power here. This one is going to r, and these two must add up to n. So plus 8c2, then we're going to do 2 to the power of 6, we'll do negative 3x, which we need to square, plus 8c3, we've got now 2 to the 5th, and we've got negative 3x, which we need to cube. So hopefully now you see that 8c0 is going to be 1. 2 to the power of 8 is 256, and then we're going to have just 1. So this to the 0 is just 1. 8c1 is 8. 2 to the power of 7 is 2. 1. What have we got? 200 and... what's that going to give us? 128, 256. So 1, let's just put that in, 128, 128. And then we're going to have now minus the 3x, or negative 3x. Now 8c2, if you wanted to work it out, is going to be 8 factorial. So if you wanted, it would be 8 factorial over now 6 factorial times by 2 factorial. So this is going to give us now 8 times by 7 over 2. And the way I've done that is cancelling the 6 factorials. So what's that, 28? So 28, 2 to the 6 is going to be 64. We need to square this, so it's going to be 9x squared. On the next one, if we wanted to, we've got 8c3. We could, of course, work that out. It's 8 factorial. And then we're going to have now 5 factorial, 3 factorial. So 3 factorial, 5 factorial. So 3 factorial, 5 factorial. So if we wanted to do this, it's 8 times by 7 times by 6 over 3 factorial. Now 3 factorial is just going to be 3 times 2 times 1, which is 6. So that's going to give us 56. Again, if you want to check that, you can do. You're not expected to do this. 8, then we have 8c3, and that's our 56. 2 to the 5th is 32, and this is going to give us negative 27x cubed. So all I do at this stage is tidy up. So we've got 256, then we've got 8 times by 128, and we just got to be careful with the positives and negatives, and then we'll multiply that by 3, and that's going to be negative. So negative 3072x. Let's check that I've got that right. Next one, 28 times by 64 times by 9. That's going to be 16128 plus 16128x squared. And then finally what we've got, 56 times 32 times by 27. That's going to be big, 48384. So minus 48384x cubed. So there we go. All I've done is used the expansion. Okay, let's do the next one, a minus 2b to the 12th. So what we'll have then is 12c0. We'll have now a to the power of 12, negative 2b to the power of 0. We'll have plus 12c1. We will have now a to the power of 11. We'll have negative 2b to the power of 1, plus 12c2. Then we'll have a to the power of 10. We'll have negative 2b to the power of 2, and then we'll have 12c3, and then we'll have a to the power of 9, negative 2b to the power of 3. They're the first 4 terms. I think the examiner would be very harsh to expect us to go ahead and expand all 12 terms. It'd be a bit of a waste of time. 12C0 is 1. Then we'll get a to the power of 12, and then we'll get 1. 12C1 is 12. We'll have a to the power of 11, and then we'll have negative 2b. 12C2, if we want, we can work this out. It's going to be 12 times 11 divided by 2. It should be 66. Hopefully my maths is stacking up. So 12C2, let's do that, 66. So 66. Then we'll have a to the power of 10. And then we'll have this term squared, which is going to be positive 4b squared. If we do 12C3, what are we going to have on that? A quick, I'll do it in the, I should really be able to do it, but again, talking and doing it, different matter, 220. So 220, and this is going to be a minus, now in fact we'll put the plus because I'll do it, 220, a to the 9th, and then we'll have negative 8b cubed. So just tidying this up, a to the 12th, we will have now minus 24. So that's going to be minus 24a to the 11th, b to the power of 1. What's that going to give me? 25, what are we going to have? 264 plus 264. So plus 264, I'm hoping that's correct, a to the 10th, b squared. And then what have we got here? What's that going to give us? 16, 17, 60. Let's just do it on a calculator. So 220 times by 8, 1760. So negative 1760 a to the 9th b cubed. That looks good. I'm getting quite tired, but hopefully that is correct. Okay, let's end with this one. Right here, we've got 2 plus x, and then we've got 1 minus 4x to the 7th. We need the first 4 terms. Now, we saw this in a previous video. We expanded the second bracket with the higher power using the binomial expansion, and then multiplied through with this single power term. So what I'm going to have is 2 plus x. We only need the first 4 terms. And then we're going to multiply this by 7c0. We're going to have 1 to the 7th. We're going to have negative 4x now to the 0, plus 7c, and then we're going to have 1, so 7c1. We're going to have now 1 to the power of 6. We'll have negative 4x to the power of 1. So all I'm doing is simply now continuing this. So if we do the next one, we're going to have 7c2. Let's just write this on, plus 7c2. We're going to have 1 to the 5th. We're going to have negative 4x, which we need to square, plus 7c3. We're going to have 1 to the 4th, negative 4x, which we need to cube. As you can see, it's often a bit of a hassle with working. So what we've got then is 2 plus x. Then on here, we're going to have now in the brackets 1. Then we're going to have 7c1 is 7. So this is going to be minus 28x. If we do 7c2, what's that going to be? 7c2 is going to be 21. Let's just check 7c2. 7c2, as my brain is starting to fry. So that is going to give us now plus, so 7c2 times by, and then we're going to need to multiply this by 16. 16, that's going to be plus, so plus 336, so plus 336 x squared. Then we'll do 7c3, so 7c3, and then we're going to times that, so that's 35 times by 64, that's 4 cubed, and that's negative 220, so negative 2240 x cubed. Okay, we need the first 4 terms. So let's multiply through, starting with the 2. 2 minus 56x, then we're going to get plus, what's that going to be? 672, 672x squared, minus, what's that going to be? 4480, 4480 x cubed. As you can see, I'm getting quite tired at this stage. Multiplying through, we're going to have plus now 1x. then we're going to have minus 28x squared, and then we're going to have minus 336x cubed. Now, if I just consider the next one, we're not going to need, and I'll just put this in a different colour, we're not going to need the fourth term, as you can see, the fifth term. This is going to give us a fifth term. So it's going to be now minus 2240x to the fourth. We don't need that. So we just need these ones right here. So what's that going to give us? 2 minus 55x, and then what are we going to have on there? What's that going to give us? 39. 39 plus 39x squared, and then let's just do this on a calculator. So negative 4480 minus a 336, and that's going to give us negative 4816. So negative 4816x cubed. They are the first four terms in the expansion. So there we go, 40 minutes and running. Hopefully that's been of some use. If the explanation was a bit above things, that's perfectly fine, as long as you can implement this and use the binomial expansion. So in the next couple of videos, we will look at some more challenging questions where we're using either Pascal's triangle or the nCr method. It's whichever is more convenient.